All right, okay, so let's move on into our next module for this week. Okay, I talked earlier just about music hardware, in this case, an analog mixer, right? Briefly talked about, what are the sort of main components and how a typical channel strip, right, is constructed, is made of, lah. Okay, now when you open a DW, it's also going to be similar. How they lay it out is exactly the same. How they, lay it out in a real, in a real analog mixer. So the next thing you want to know, very, very important thing, again, if you are going to be working with any sort of music production or audio, it's a very important skill to have, right? Is to understand about your signal flow and your interconnects, right? Interconnections. Now, so this is a typical signal flow, right? For, let's say, we're recording. It's always very important to understand, right? It's one of actually the foundational basics lah of both audio engineering and music production. Yes, I know, right? Some of these more technical things will be a little bit boring. Some people may not be interested. A lot nowadays can be done within a computer, as I said, right? Or you just drag and drop stuff and all of this. But if you ever go a little bit further, if you start recording vocals, right, for example, or if you start recording, some real instruments, maybe a bass or a guitar or keyboards or even external, maybe an external synth or drum machine or a sequencer, understanding the signal flow is going to be very, very important. Okay, now understanding signal flow is also important to troubleshoot. What if, alamak, one day you encounter, oh, I'm not getting signal, oh, I'm not getting sound, right, in my setup. But if you are so accustomed to doing everything inside a computer, then you won't figure out. You were like, oh, how do I connect? How do I plug all this stuff? Why am I not getting sound? Or something like that. Understanding signal flow will always be the core, one of the core foundations. So very briefly, okay, let me just kind of describe to you. Now, so you see the orange, right, dotted lines, right, are analog. It's an analog signal. And blue is when you enter into a digital domain. So we have, first of all, your sound source, your vocalist in this case, right? Your singer or rapper. He or she sings into a microphone, right? The microphone goes into your mic preamp, right? Be it an external one, or is it on your interface, or you're using a mixer. And then from there, it goes into an AD converter. Again, AD converters are everywhere, right? Because again, same question I get with the mic preamp. Oh, do I have to buy a separate AD converter? Your interface actually is your AD converter already. Okay, so it's already there. Right, then finally it goes into your computer. Okay, this is it. Mic preamp, AD converter. Right, as I mentioned earlier, we're talking about digital audio. You need to convert your analog signal into digital signals so that the computer, right, so that your software will understand and know how to process it. So once it's into the computer, you have your DAW, you have technically it goes into, your data goes into your hard drive or your flash drive or SSD drive or whatsoever. And inside your software, right, your same thing, volume fader, panning, your outputs, your master, and whatever lah, your auxiliary sense, your effects or whatsoever internally. Then once it's inside a computer, it needs to get out, right? It needs to go back out into his speakers or headphones. So the opposite process will happen, right? You have a digital to analog, a DA converter, out into your headphone amp, okay? Or, it could be a power amp for all that matter, or powered speakers, headphones, and then pop into your ears. Okay, so this is a little bit more detailed analytical look at how signals actually flow. So it's important to understand, okay, where a signal flows, because it also helps you to troubleshoot. Now, one key role, now this is not something that's kind of explained, right, or something that's in my notes. Troubleshooting, whenever you encounter a problem, there should always be a process, right, of identifying where the issue problem is. And it's always based on signal flow. Let's say, for example, vocalist, right? Then suddenly, oh, no sound. Where do you check first? What's the first thing you check? Obviously, if everything looks fine, right? Your mute button is fine, your interface, your gain is up. So let's not take a situation where, oh, you accidentally muted. Your speakers are on, everything is on, all right? Everything is running, but you're not getting sound. How do you troubleshoot? What process is there? Follow your signal flow. Following signal flow is kind of the best procedure. It's not the best. It should be the process and the procedure of troubleshooting and finding out faults. Now, because here's the thing. If you just randomly take, let's say, interface and check on the interface, you may get lucky and then find out, oh, yes, yeah, it turns out that was the reason why. But it does not rule out, it does not give you 100% certainty. But if you, let's say you check, let's say the mute button, right? And it's operating and it's fine, you're still not getting the signal. You still haven't arrived at a solution yet. You still don't know what is the situation. So the only way to be always 100% certain you are identifying what a real problem is to always follow signal flow. Firstly, check microphone first, right? Are you sure, confirm you know that the microphone is working or not? So if you know that it's a working microphone, but you're not getting a signal, the only way to check and to test again is to try a different microphone. So you plug another microphone in. That's why sometimes it's good to have a cheap, inexpensive microphone, like maybe SM58 or even cheap dynamic mic, just to test, make sure. So if that gives you signal, poop, you already know for certain, oh, that means my microphone has a problem. If you have ruled out that it's not the mic's working, then you move on to the next. Check your preamp, check your gain on there, right? And so on and so forth lah. That's the only way to sort of rule out, because let me give you a better example for guitarists, right? So you know lah, guitarists, sometimes they have pedal board, right? Wow, they have like, maybe some guy will have a massive pedal board, 10 pedal boards there. Play, they plug in, oh, no sound. How are they going to identify where the problem is? They always have to follow the signal flow. They have to start first, check. Is it my guitar the problem? So bypass it, just straight away plug into the amp. Oh, got sound. Okay, that means I know, right, that the problem is somewhere in the pedal board. You always start with a signal flow. But if you take the guitar, right, the next step, take the guitar, plug into amp, still no sound, but you know the guitar is working fine. What's the next thing you check? Cable. Switch out the cable, right? And then if suddenly got sound again, oh, then you know lah, oh, actually it's a cable problem. But if you switch out the cable and oh, cable is working fine, then you plug into this, then you have to troubleshoot one by one. Start with the signal flow and identify where the problem is. Okay, so you get what I mean by signal flow is very, very important, right? So understanding signal flow is really, really key to a lot of things lah, right? How to solve problems, how to figure out things. It's all about signal flow. All right. Sorry for harping so long on this topic, because I think it's very, very important lah. It's something that it's kind of getting lost. Obviously, when everything moves into computers and all that, but it's still important. It's still important because you still need your interface. You still need to select your inputs, and you still need to route. You still need to know where your signal is kind of moving in, even though it's inside a computer. All right, because otherwise you always be confused, not knowing where the issue or the problem is. Okay, moving on. Okay, this is actually a very short slide only, but I can talk so long about the signal flow. Let's go straight away into interconnects, okay? So need to be familiar with all this stuff and the cables that you're going to be plugging into. Right, so very, very briefly, the first one, right, and the one we all know very, very well is called the XLR, okay? Right, or what we call your mic cable, all right? So this is your XLR, right? So XLRs, the 3-pin version, as you can see here, it's got 3 pins, is the most commonly used in audio. Now you may not know, right? XLR also, there can be more than 3 pins. Can be 5 pin, can be 7 pin, can be 9 pin. Okay, 9 pin, I don't know whether it's 9 pin or not. Okay, but I know there's 5 and there's 7, okay? Right. So for example, when we were recording your drums on week 1, the stereo microphone, that uses a 5-pin XLR, right? Because that's what you need. You need your 5 pins to be able to carry stereo signals, you see. Oh, also in 4 to 7 pin configurations. Okay, right. So it's in my notes already. So, right, 4 to 7 pin, right? So there's no 9 pin. 9 pin only is with DIN. Okay, now, what does it carry? It can carry microphone, obviously, right? It also carries your line level signals, but like you may not know, it also carries digital. It can also carry digital audio signals, right? In the form of what we call the AES and EBU digital format, right? The digital interface format. Again, you can refer back, right, to the notes of week 2, right? When we talked about digital audio. So there are, of course, right, male and female versions, right? All the cable, all the connections and all that, right, have male and female versions for reasons which I do not need to explain. Okay, so one cool thing about the XLR, right, is the locking mates, the locking mechanism. So XLR was first developed and invented and patented by the Canon company. So right? CANNON, right? But not the cannon that you used to shoot, lah. Okay, not those kind of cannons. So they were called Canon connectors, Canon cable, because that was the company. But XLR now is the more common, is generally known, lah, right? XLR. The locking mechanism is something that they developed, and it allows you to daisy chain, right? So as I remember, daisy chaining means you can daisy chain and you can chain, right, many cables to make a long cable. So that was very clever of them to come up with this design. So this is medium to long wearing. Okay, so meaning that it's quite tahan lah. You can last and you can tahan quite well. All right. So live sound, it can be thrown around. Okay, I'm not saying that you want to throw around and disturb, but it can take a bit of abuse lah. Okay, so the next most common connector that you'll find is what we call the quarter-inch. All right. So the actual technical name is called the quarter-inch phone. There's several versions, but the most common that we encounter are what we call the TS and the TRS. TRS, right? The T here stands for tip, the R stands for ring, and the S stands for sleeve, right? So you can see the top there, that is a TRS, and you see the bottom one is called the TS. So the TRS here is actually referring to the actual connector. You have the tip, right, the very further end. You have your ring, which is the middle band here, and then you have your sleeve lah. So it's the 3 connectors. TS, on the other hand, you can see is only 2, right? There's only one of that black, the insulating band over there. So these are also, all right, obviously available in your 1/8 inch size as well. So the size that plugs into your phones, some of the consumer headphone outputs. It carries your line level and can also carry your headphone level signals. It can actually also carry mic level, but usually in most applications, when we talk about quarter-inch, right, we are dealing with line level, headphone level, and even instrument level signals already. Okay. Now these can be either balanced or unbalanced. Okay. Again, I'm not going to go so much detail into that. Now these are low cost and kind of medium wearing lah. Okay, right? They're not as long lasting or as robust as XLR, but still okay lah, right? You still have to make an effort if you want to damage it. Now, a quick side note again, right? A very quick side note. A lot of people always confuse the TRS. When people see a TRS cable, some people will say, oh, that's a stereo cable. But a more technical engineer guy will usually say, oh, that's a balanced TRS cable. Whether a TRS cable carries a mono or stereo signal, you cannot determine just by looking at it. You cannot just look at it and say, oh, this is a stereo cable. It's always based on the application, on where it is used for. This is an important thing that you want to be aware of lah. Okay, so just a quick side note. Right, moving on. Right, you have the RCA. Oh, by the way, sorry. All right, the reason why they call it the phone, the name phone, is because this was actually the design of the jack that's actually used back in the old days, where it used to be, if you wanted to make a phone call from one another, you had to dial the operator. The operator, right, have to physically take the jack, connect, right, let's say from this part of the town to this number. So This was actually the design. That's why it's called the phone jack, because it's so widely used in telecommunications and so that's why they kept the design until this day lah. So that is why it's called phone. It was used in telephony, telecommunications back in the day. Next one, RCA, right? Or phono. This is the bane of all the sound engineers' existence. Okay, it's like, oh, we really hate dealing with RCAs. God, always got problem one. Always like, alamak, signal intermittent lah, right? No sound lah. Especially when trying to hook up or set up for a DJ. Okay, always got problem one. I'm talking to that from experience because I have a DJ in my band. Okay, so always RCA got issues. So RCAs, right? RCAs are designed to carry line or headphone level signals, right? They don't carry mic level signals. And the nature of design, they are unbalanced. One main thing about balance and unbalanced is, right? The difference is in the wiring, how many cores and how many wires are inside a balanced cable or a balanced connection. But basically, balance is usually better, right? Because firstly, it preserves and it maintains the signal much better. The second benefit of balanced cables is, right, it is much more resistant and it helps to reject noise. So any, kind of electrical noise, RF noise, radio frequency noise, electromagnetic noise, a balanced cable is much more better at eliminating and rejecting the noise. Not so when you deal with an unbalance. So that's why when you have a guitar, a normal instrument, a guitar cable, you go near a light source or electrical source, bzzz, you get a buzz and all that because it's an unbalance, right? It doesn't have the ability to reject that noise, the electromagnetic, and the RF noise that's being picked up. Whereas you have a microphone cable and all that, right? You can have a mic cable running a long distance, hundreds of meters or something like that. You barely get any noise out of it. You can also carry both audio and also video signals, right? So in this case, right, we're very familiar. Sometimes we see the white and the red is usually carrying your audio, and your yellow is to carry your video signal. Oh, one tip when you deal with RCAs, or actually generally any kind of a cable which you see, you just remember this phrase, right? Red is right, right? Red is right, because white and red you don't know which is left, which is right, right? So always this is the key. Red is right, okay? So red one, plug into right. Okay, this is a low cost, very simple design, okay? And obviously, right, low cost simple design, easy to spoil lah. Now, let's move on. Next one, what we call the BNC, okay? BNC here is a type of, it's a coaxial. It uses coaxial cables. So you can use this for both analog and digital audio, all right? I'll speed through this a little bit faster. Very common for video and your radio equipment, right? So video crews will be very, very familiar. Now in the studio, it's used for your word clock, digital word clock signals, okay? So this is what we call a bayonet mount. You know what a bayonet is, right? The army soldiers, you can fix the knife, the bayonet onto your rifle. So it's like that. You lock it in, then you like twist. That's what we call a bayonet mount. So it's very secure, all right? Once you lock and twist it, right, it's very, very solid. It's very hard to pull out. Let's go further forward. We have the DIN, okay? So DIN, very familiar when we come to MIDI cables. So this is actually a 1, 2, 3, 4, 5, 6, 7. It's like an 8-pin DIN. So DIN, short for Deutsches Institut für Normung, DIN, right? The German National Standards Organization is like our SIRIM lah, all right? We have our SIRIM. So in Germany, they have their DIN. So they are the one who came up with this design. There are actually many different kind of DIN standards, right? So it's not just one single standard, but the one that we are very, very familiar with is the 5-pin type, which we use for MIDI, okay? Okay, moving on. Next one, ADAT optical. Okay, this one, an optical cable. This is a fiber optic, right? So meaning, the data is being transmitted using light signals, right? So if you ever plug in an ADAT cable from one side, from an output, you shine, oh, got light one. I don't recommend looking into it lah, okay? Because you might blind yourself, okay? Right. So right, it uses what we call the toslink connectors. This is used to carry digital audio, right? Either the ADAT format or you used to carry SPDIF. So it can carry up to 8 channels of 24-bit, 48 kilohertz audio. So one cable, one single ADAT connector can carry up to 8 channels. Or if you upsample it, if you are transmitting at 96K, only up to 4 channels. So obviously, because it has a certain limited bandwidth, ADAT has an embedded clock signal in it. So what this means is that, it also sends in the clock signal. So you don't need like an external synchronizer if you're just using one. It is also hot pluggable. Okay, hot pluggable means that if the device is running, you can just unplug, plug, unplug. Usually safe, and I've done that. Okay, generally, again speaking, whenever you're plugging or unplugging things, it's always best to turn your volume down, lah, right? Or switch off or mute whatever your outputs to your speakers is. Okay. So even though it says hot pluggable, okay. So the commonly used type connectors in audio. So this little diagram here, right? We've gone through some of them. I mentioned you have your ADAT, which we just saw, Firewire, okay, which is dying, okay, or I would say is dead, but there are still some studios and some devices which still hang on to some good old, Firewire interfaces, okay. USB, you have your RCA, right, which transmits SPDF, XLR, BNC, your TS and TRS, your RCA, all right? So again, see, RCA is not only used for audio, all right? RCA can also transmit SPDIF also. And then lastly, the one on the right, just to recap, this is a typical 5-pin MIDI. So that gives you a brief kind of an overlook about signal flow and the types of interconnections, right, that we use and when we apply, okay? Let's move on to the next and the final topic for today.